Okay, hello everyone. I thought I would just add this in as something that's not quite in the lecture notes, but may be useful for various things. Uh, for example, writing down all the possibilities in a truth table. And it's just how to write in binary. I know some people will have seen this before, other people won't have, but it will just help you to do things in a more consistent fashion. So let me just make the point about this is going to be writing in binary. And this isn't examinable, it is just useful to be able to do. And it will come up in various places. Right. So, in first of all, if we want to write in binary, we want to just remind ourselves what things are like in the decimal system. So this is so decimal this des part, it means 10. So this is base 10. And what you do when you've got a number, so if I have, just say 357, then this, as you know, is the units. So just a way of telling you what it would be if you forgot every multiple of 10, then what number you would be left with, basically. And this are the tens, this second one along. So these are what you would get if you forgot everything about the hundreds. So if you were able to take off as many hundreds as you liked, then that's the number you would get. And then you also know the units, so you can take those off, and then you get this 5. But this is the hundreds. And what this means is 7 times 1 plus 5 times 10. So we want 7 ones, we want 5 tens, and we want 3 hundreds. Okay, I'm sure this is all very familiar. So what do you do when you work in binary? You just swap the multiplying by 10. So we go 1, 10, 100. We just swap that process for multiplying by 2. And if we do that, then the units are going to have to go up. They're going to be 0 or 1. And as soon as you get to 2, then you're going to go over to the second column. So 101 in binary. So this means exactly the same. So 1 times 1 plus 0 times, this time instead of a 10, it's a 2. And then 1 times, this is 10 squared. So 2 squared is 4. And if you then add that up, you get 5. Okay. So now we can count in binary. And this is the bit that's kind of useful, because sometimes you need to just go through all the possibilities of things that could be in sets or outside of sets and so on. Start with 0. It's always a good place to start. And now we're going to just keep adding 1. So this is 0, then I get to 1. Now I want to add 1 to this again. So what I'll do is I'll go to here and I'll just do that to show you that that's the answer, and then we'll have a look at why it's right. So if I do 1 plus 1, So doing this, it will give me a 2, but I can't put a 2 because I've only got the numbers 1 and 0. So what I do is I would do what I would do in decimal. So let's go back to what I would do in decimal. If I have a 9 and a 1 and I add them together, I can't put 10 because there's no symbol for it, so I put 0 and I carry a 1. And then I see what's down here, and then if there's nothing else, then I get a 1. So it's going to be the same thing here. We don't have a 2 symbol, so we're just going to put a 0 and carry a 1. And then that gives us this. Okay, and then if I want to do this plus 1, add those up, I get a 1. That's fine. 1, 1, 1. Let's do the next one. So 1, if I add 1 to this, I'm going to get 1 plus 1 is again 0. I have to carry a 1, and now I get 1 plus 1 is 0, and I carry a 1, and then I get a 1. And you just keep going like this. So you're copying basically what you did already. We've got 0, we've got 1, and then we're going to do when we add 1 to this, we're going to carry a 1, and then we'll get a 1, 1, 0. And when we add 1 to this, we get this, and then when we add 1 to this, well, we get we're going to get 2, and then we carry a 1. So then we got 1 plus 1, which is 2, and then we carry a 1, and we get 1 plus 1 is 2, and we carry a 1. So it goes on like this. And this can be a useful way to enumerate all the possibilities for things. So being able to reproduce this is quite a good skill.